Hey guys, my name is Trevor Sullivan. I'm a solutions architect with Stratusgrid, and Stratusgrid is a premier partner with AWS for consulting services in the cloud. Plus, we also have a product, a software as a service product called Stratosphere, which you can access over at our site here, stratusgrid.com. You'll see Stratosphere FinOps up here. This is basically a tool that helps organizations to cost optimize their AWS environments and really get the most value out of their cloud platform. So if you're interested in talking about Stratosphere, feel free to reach out to us. Just hit this Let's Talk button right up here in the upper right-hand corner, and we would love to walk you through what Stratosphere is capable of. So the topic for this particular video is going to be another AWS service called AWS Resource Access Manager, or RAM for short. Now, as you may know, there's lots of different services in AWS that allow you to kind of manage a large organization. We've got the AWS Organizations service, which is used to kind of build an AWS account structure. So if we go over to AWS Organizations here, we can see that service. And in this organization here, I've got a bunch of sub-accounts in what's called an organizational unit. You can kind of think of an OU like a folder where you can have a bunch of different AWS accounts. And then I have the root account itself that's kind of the parent account for my AWS organization that I'm currently logged into right here. So this account, just keep this in mind, it's 2111. That's what it begins with here. And then these sub-accounts right here all belong to the same organizational unit. Now, as I am building out various types of resources, whether it's VPCs or EC2 placement groups or a bunch of other supported types of resources, AWS Systems Manager Parameter Store is another example of where you might want to share out various resources. I want to be able to define those resources a single time, right? So in the case of a VPC, like a VPC subnet, for example, I might want to create a VPC inside of a centralized networking account, but then I want to be able to share out access to those VPC subnets with other accounts within my AWS organization. Now, the Resource Access Manager service is what allows me to accomplish that. So I could go to my parent account here, the 2111 account, and create a VPC, and then I can share those VPC subnets that I create, not the VPC itself, but just the VPC subnets with all of the accounts under this organizational unit. Now, you don't have to use AWS Organizations to use a Resource Access Manager. You do have the ability to actually share across just distinct AWS accounts without using AWS Organizations. However, if you need to share out resources with a large number of AWS accounts, then AWS Organizations is certainly going to be the easiest solution for you to accomplish that. So what we're going to do is take a look at some of the resource types that are supported. Just keep in mind that Resource Access Manager does have a pretty limited list of resources that are supported for sharing. So for example, a Lambda function can't be shared between accounts, or an S3 bucket can't be shared between accounts. So just be aware that it is somewhat limited in its capabilities, but for the resources that are actually supported, it's very helpful to be able to define those resources a single time and then share out access to them. So this simplifies management of resources, plus it also reduces cost. Imagine if you had to build out a VPC with an internet gateway, a NAT gateway, and all the supporting resources to make that VPC work, and have to replicate that for every single account. That wouldn't necessarily be scalable from either a management or a cost perspective, right? Because you have to pay for things like NAT gateways. So rather than doing that, we can just define our VPC once inside of our central account with a NAT gateway, just have a single instance of a NAT gateway, and then be able to use those public and private subnets from our other AWS accounts. Same thing applies for things like Systems Manager, advanced parameters. So if we go into the Systems Manager service, there's a service called Parameter Store under the Systems Manager service, and this allows us to define secrets. So we can create parameters, things like maybe a DNS endpoint for a database server, or a username or a password to access a database server as a particular user. We can store those types of credentials inside Parameter Store, and then we can share those parameters with other AWS accounts inside of our AWS Organizations environment. So your question is probably going to be, what resources are actually supported by Resource Access Manager? To get that list of resources that are supported, you can either go out to Resource Access Manager and then say create a resource share, and then go under this resources section right here. And this is going to show you all of the different types of resources that are supported. And again, it is pretty limited. So there's only certain services that are supported. And then within those certain services, there's only certain types of specific resources defined by that particular service that are supported for resource sharing. So we can see we've got some SageMaker things here. We've got VPC subnets. We've got traffic mirroring targets. We've got transit gateways. We also have things like EC2 placement groups. We also have things like outposts, for example. So if you have a physical rack using AWS Outposts, you can share that amongst multiple AWS accounts, which is pretty interesting. We also have EC2 dedicated hosts. So this is really convenient because if you're provisioning a dedicated host, which is kind of like a bare metal EC2 server that's sitting in a data center somewhere, we can actually take that dedicated host and then share it with other AWS accounts so that when you provision EC2 instances on top of that dedicated host, you can use the same dedicated host across multiple accounts without having to provision separate and multiple dedicated hosts for each AWS account, right? So that's where some of the cost savings comes in. We can centralize things, simplify management, simplify our cost savings as well. So it's a really great feature here, but you got to keep in mind some of the limitations that it does have. The other way to find out what resources are supported is to look at the documentation for the AWS Resource Access Manager service. And so if we go over to the RAM documentation here, take a look at this document right here called Shareable Resources. Now, this is going to go into detail about the services that you can share resources with, and within those services, which specific resource types. So if we scroll down a little bit and find the Amazon EC2 service here, you can see that we've got capacity reservations. We've also got dedicated hosts. We have placement groups. And then if we search for things like VPC, you can see that we've got things like IP address management pools. We've got support for prefix lists, and we've also got support for subnets. Now, one important thing to note is that when we share out a subnet, right, we want to share access to that subnet across multiple AWS accounts. But when you provision something like an EC2 instance, or let's say an RDS cluster or something like that, you always have to have an AWS VPC security group that's attached so that you know what inbound and outbound access rules are available, right? Now, even though we can share a subnet through Resource Access Manager, we cannot share VPC security groups. Remember that a security group is bound directly to a VPC. It's not bound to a subnet because subnets are tied to specific availability zones, whereas a security group is just a generic concept that can apply to any availability zone. It just needs to be associated with the VPC where the resource is being provisioned inside of based upon its subnet association. So the VPC security group cannot be shared across multiple AWS accounts. We have to actually go define a separate security group that's bound to the VPC in a separate account. I know it's a little bit confusing, but then inside of the account where we're actually provisioning the EC2 instance, we have to make sure that we have a VPC security group in that same account as the EC2 instance, not the same account as where the VPC itself is actually defined. So I hope that makes sense. We'll kind of step through things here so that you understand how that works. Also, something else that is notable about sharing out VPCs, VPC subnets, I should say, is that you cannot share out the default VPC for a region. So when we provision a VPC, it has an attribute called the default VPC for a particular region. It's kind of an old concept in AWS that's not really relevant anymore, not super relevant, but basically we can't share out any subnets that belong to that default VPC. We have to create a separate VPC that's not the default for the region, and then we can share those subnets out. So the default VPC subnets simply will not show up in the resource sharing right here. So if I try to create a resource share and list subnets, you're going to see that nothing shows up here. So what we're going to do for starters is to create a VPC and then share it out with some other accounts. And just as a reminder, over here in the AWS Organizations service, I have a couple of different containers here in my not Docker containers, but Firefox containers here so that I can actually log in as one of these sub accounts here. So I'm going to be logging in to the sub account 6546, and I'll try to make sure that I call out anytime that I'm context switching between AWS accounts so that we know if we're working in the root account where we're going to define the resources, and then the child account where we're actually going to share those resources with, okay? So on this orange tab up here, I'm going to be logging into the child account, and then the non-colored one up here is going to be the parent account or the organizational root account. So what we're going to do for starters is to go over to the VPC service, because I'm going to create a brand new VPC that we can then share the subnets with, so it's not the default VPC. As you can see under VPCs right here, if I just scroll over a little bit horizontally here, you should see default VPC is yes. That means that we can't share out any subnets that are associated with that particular VPC. So of course we need to create one. And the easiest way to create a new VPC is to go to the VPC dashboard here, click on create VPC. It'll say VPC and more. It's kind of like a little wizard here. And then I'll just call this Stratosphere 01. I won't assign any IPv6 blocks here. For availability zones, I'll just say do 3, and then we'll say 3 public subnets, 3 private subnets. We'll put a NAT gateway in a single availability zone. We'll disable VPC endpoints. And then I'm going to add an owner tag down here just so that my other teammates know that I was the one who created this VPC environment here in case it needs to be cleaned up in the future. So this will go through, create all the public and private subnets, create the internet gateway, attach it to the VPC. It'll create the NAT gateway, set up all the routing tables and things like that. The NAT gateway does take a couple of moments to spin up there, so we'll just go ahead and let that run in the background for now. But then what we're going to do for now is go over to the Resource Access Manager service. So I'll just open that in another tab. Again, I'm in the parent account 2111. And now I want to create one of these resource shares in the AWS Resource Access Manager service. So I'll click on Create a Resource Share. And then for the resource share name, I'll just call this Stratosphere 01. I'm not going to put a resource type in the name because we can actually share multiple resource types in the same resource share. So under the resources that I want to share out, I'm going to choose the VPC subnets here. And as you can see, I have a list of these 6 subnets that belong to the non-default VPC that we just created. So I could choose all of these subnets to share with the other account. And then down here, you can see we've selected these particular resources here. And then for the resource share itself, that's a resource, a separate type of resource. So I'm going to say owner Trevor Sullivan, just so that if anybody's looking at the resource share, they know who created this. Now, something that's interesting about the Resource Access Manager service is that you actually have a separate permission set here that assigns certain permissions to the receiving account or the account that resources are being shared with. Now, one of the things that you can do is to create what are called customer managed permissions. And so you can actually create your own custom policies to limit who is able to access the resources in a particular share. So even if somebody in the target account that we're sharing with has access to manage all subnets, we could actually add an additional layer of filtering to the permissions so that they cannot access subnets that have been shared through the resource access share that we're creating here. So just keep in mind that there is that separate feature that allows you to define further policy permissions on resource shares. Now, this final page here, step 3, is to grant access to specific principals. And so what we can do here is say, I want to display my organizational structure. And as you can see, I've got this OU here that has 5 different child accounts. So if I want to share from this parent account down here with these 5 child accounts, I can just check off the organizational unit, and that's going to share these subnets with all of those accounts all at once, so I don't have to individually select them and do the whole invitation process that you would normally have to do if you have just disparate AWS accounts. You'd have to create a resource share, and then the other account would have to go accept that invitation to share those resources so that they'd then become available. But in this case, because everything belongs to an organization, or all the accounts that we're dealing with belong to an organization, we can just check off that OU and make it really easy here. Also, down here, we have selected principals. So this is just going to show us what we have selected from up here. So we can just go ahead and click on the next button here, just confirm everything looks good, and then hit Create Resource Share. Now, one other thing I wanted to point out is that we kind of skipped over this, but you do need to make sure that you enable the Resource Access Manager service for your organization. So we're going to take a little step back here, and we're going to go back to the Organizations service right here. There's two different places that we need to check. So one is under Organizations, go to Services, and then if we scroll down in the list of services right here, we should eventually see the RAM service. So here it is. And as you can see, I actually enabled access to it yesterday. And so there'll be a button here that says Enable Trusted Access. So go into Organizations in your root account and make sure you enable that feature. And then go back to the Resource Access Manager service, go down to Settings here, and then make sure that you check this box that says Enable Sharing with AWS Organizations, and that'll make sure that you have access to share resources with organizational units in the AWS organization. So that's a really nice feature that just kind of integrates Resource Access Manager and organizations together. All right, so now that we have created this resource share right here, we can go to our target account. So I'm going to switch contexts over to the orange tab here. And what we're going to do is navigate to the VPC service. And under the VPC service in this child account, we're going to be looking for the subnets that belong to the VPC. Really quickly, I'm going to go back over to the parent account, go to the VPC service once again, and I just want to look for the VPC ID so that I can filter the list of subnets for that particular VPC. And then we'll come back to the child account and actually do that filter so that we can see those subnets. So in the VPCs here, the Stratus Grid 01 VPC that I created starts with 0DC6. So I'll just go ahead and copy that to my clipboard right down here. Let's come back to the child account, go to your VPCs, and check it out. We actually have 0DC6 showing up in there, even though I'm in the 6546 AWS account. So if I click on that VPC and take a look at the Amazon resource name for it, which I don't see showing up down here in the details. Let me take a look at Citer's resource map. I'm not seeing it show up here, but this does actually belong to a different AWS account. So if I scroll over here, you can see the owner ID field is the 2111 account. Actually, that's right down here as well. So there's owner ID. They don't show the ARN, but they do show the owner ID from the ARN. And so we can see that the account that we're currently logged into and the owner ID are actually completely separate. So we know that that resource access sharing is working correctly. If we come over to subnets here, we can apply a filter to that same VPC. Oops, we actually want VPC, not subnet ID. And then we'll filter to 0DC, etc. And as you can see, we get 6 results here, 1 for each of these subnets. Now, one thing I do want to point out is that even though we have shared the subnets across AWS accounts, there is certain metadata that does not get shared between the accounts. As you can see, these subnets here don't have a name tag, right? And I also added an owner Trevor Sullivan tag. So if I take a look at the tags on the VPC, you can see there's no tags on the VPC. And if we take a look at the subnets and go over to the tags section here, you can see there's no tags associated with this resource either. And the VPC also doesn't have a name here. But over here, that VPC that starts with 0DC6 does have a name tag, and it has owner Trevor Sullivan. So keep in mind that the tags for those resources don't get shared across the AWS accounts. We only have access to the resource itself, not the tag metadata. All right, so let's switch back to the child account here. And now what we want to do is create a security group, because remember, we do not have any security groups associated with that VPC. We share the subnets, but we don't have a security group that we can assign to an EC2 instance. So we'd either have to create one while we're creating an EC2 instance using the EC2 instance creation wizard, or we can just create one in advance and then reference it from the EC2 wizard. So let's create a new security group here. And I'll add a standard rule that allows inbound SSH traffic from any public IPv4 address. We'll just call this SSH inbound, give it a name like Stratus Grid 01 RAM shared EC2 SSH. We'll say allows SSH access for the description. And we want to make sure that we choose the 0DC6 VPC for the VPC that we're going to associate this security group with. All right, so actually we want an inbound rule here. I almost added that to outbound instead. So for outbound, we're just going to say all TCP and just move that description up here and allow from 000. Okay. So now I'm going to give this a tag here, owner Trevor Sullivan, just good practice to do that so people know who's creating it. And then we'll hit create security group. All right, so now that the security group has been created, remember that the security group belongs to the child account, not the parent account where the VPC itself was actually created. So just keep that in mind. The owner of the security group is different than the account that owns the VPC. And I know that sounds kind of weird, but that's just how Resource Access Manager works. With VPC anyway. All right, so now what we're going to do is head back over to EC2, and I'm still in the child account here, and we're going to launch an EC2 instance into a public subnet. We're going to associate the security group that we just created in the child account here, that's the subnets have been shared with, and you'll see that it works perfectly fine. So let's go to launch instance. I'll just call this Stratosphere 01-RAM. I'll choose an Ubuntu image here. I'll go ahead and choose ARM-based architecture here. And then we'll do a T4G Nano. That should work perfectly fine for our use case here. For the key pair, I'll just proceed without a key pair. And then for the network, this is where we want to change the network to the 0DC6 VPC. And then we can choose a subnet. But remember that the subnets don't have a name tag, so we can't actually see which of these has a public or private name tag. So what we'd have to do is kind of cheat, go to the parent account here, take a look at the subnets here. Let's just sort by name. And then what I want to do is find one of these public ones here so I can have a public IP address associated with it. And so I'm going to choose this one, 0846. So I'm going to just kind of remember that, 0846. Come back here to the wizard, and we're going to look for the subnet 0846, which just so happens to be this first one that is selected. We'll also choose to auto-assign a public IPv4 address so that we could SSH into it if we had a private key or a public key associated with it. And then under security groups here, keep in mind that the only security group that we can see is the one that we created in the same account that the subnets were shared with. We don't have access to select the default VPC security group or any other security groups that were created in the parent account right here, right? So if we take a look at security groups and then filter to security groups that were created under the 0DC6 right here, you can see that we have the default one that belongs to the parent account here, but then this one down here belongs to the separate account. So we can't see any of the VPC security groups in the child account that were created from the parent account. But the parent account apparently can see the security group that was created in the child account. So a little bit confusing, but once you play around with it, it kind of makes sense. All right, so I'm going to go ahead and just bump this up to, let's say, 10 gigs. Under advanced details here, I'm going to go ahead and choose an instance profile that I've pre-created that allows access to the systems manager service. So I could use the session manager service to actually connect to this, even though I don't have a public key associated with it. And then I'm going to choose the spot instance option down here, and we'll just say persistent, and we will set the interruption behavior to just stop it. So I can always restart it if it gets stopped. All right, so let's go ahead and launch this instance here, and it should work perfectly fine. So we've launched an instance into a subnet that belongs to a different AWS account. If we refresh right here, sure enough, you can see that. If we go to the networking tab for this, you can see that the subnet it was associated with is subnet 08464, etc. And so that's basically how sharing subnets across AWS accounts works. So we'll give that a second to come up, and then we could connect to it using the session manager service. Once the agent for systems manager comes online, that feature should work just fine. But I also wanted to show you how we can share other types of resources. So remember, on the shareable documentation here, shareable AWS resources, we can share other things like placement groups. So if we want to cluster a bunch of systems together on the same rack across multiple AWS accounts, we can do that. If we wanted to provision an EC2 dedicated host and then launch instances on that dedicated host across accounts, we can do that as well. We can also provision things like parameters, but only advanced parameters, not standard parameters in the Systems Manager parameter store feature. So what we're going to do is start out with the placement groups, since that's another EC2 feature. So I'm going to context switch back into my parent AWS account, which is the root account for the organization. We'll switch over to the EC2 service here, and then I'm going to create what's called a placement group. As you can see, I've already got a placement group here called Stratusgrid 01, but I'll just create another one called Stratusgrid 02. We'll choose the cluster placement strategy so that we can keep machines clustered together. There are a couple of other placement group styles called spread and partition that kind of keep them separate for more higher availability use cases. And then I'll add a standard owner tag, Trevor Sullivan, to that resource as well, and we'll hit create group. All right, so now we've got this new placement group. I'll come back to Resource Access Manager, go to my existing resource share that we've already shared with the entire organizational unit of child accounts. And then I can just click on modify here. And under the resources section right here, I can say, all right, I want to share a placement group with another account. And I could check off whichever ones I want to, either one or both. And then I can go ahead and just click on the next button down here and then say, choose the managed permissions. I'll just use the default managed permissions, say next. We've already shared with the OU, so I don't have to change the sharing settings. Hit next. And then finally, we'll say update resource share. So now we're going to context switch back to the child AWS account here that belongs to the OU that we shared with. We're going to go to the placement groups, which is right down here. And as you can see, Stratusgrid 02 has now been shared across accounts here. So now, if I wanted to, I could actually launch another instance into a different, into a placement group. So let's call this Stratusgrid 02-RAM placement group test. And then we'll choose Ubuntu here. We'll choose ARM-based architecture for that. We'll choose T4G Nano. Actually, let's do a C7G. I think certain instance types don't work with placement groups, and I think the burstable may not work with that. We'll leave the key pair name there. We're going to change the VPC settings over to our other VPC. So we'll do the 808464. We'll do auto assign public IP address. We'll choose the existing SSH security group that we already manually created. We'll bump up storage to 10 gigs. Under advanced details, there are some limitations with placement groups and spot instances, so I'm just not going to choose spot instances at all, but I will choose my instance profile here, and then we'll go ahead and say launch instance. All right, so it's telling me to, let's say, proceed without a key pair. I thought I already selected that, but apparently I did not. And as you can see, we launched that instance just fine. All right, so here is our other instance. And if we look at the placement group configuration, let me just see if I can find that in this list. Let's do a search for placement group. And there we go. So we've got placement group is currently empty, but let's just refresh that really quick. And eventually that should populate because we actually didn't select a placement group. I totally forgot to do that. So let's go ahead and just terminate this instance. Then we'll relaunch once again. And I meant to do that under the advanced details. Let's call it Stratusgrid 02, placement group, Ubuntu. We'll do ARM. And then we'll say C7G medium. We'll say no key pair. We'll say VPC, choose the other VPC, say auto assign, and then we'll say select an existing security group. Perfect. Change the storage to 10 gigs. Now under advanced details, choose my instance profile, and this time we're going to correctly choose the placement group. So under placement group, we're going to say Stratusgrid 02 with the strategy of cluster, and this time it should work the way we expect it to. All right, so launch that, come back to our instance list here. Here's the new C7G that's currently initializing. And if we scroll down just a little bit in the settings here, we should see placement group is now set to StratusGrid 02 right over here on the right-hand side. So as you can see, we are able to share not just subnets, but we can also share placement groups as well and keep those instances close together, even though they exist across different AWS accounts. All right, let's try parameters really quick, shall we? So we're going to come back over to our parent account. So I'm going to context switch once again. And in the parent account here, I'm going to go to the Systems Manager service. And under Systems Manager, we're going to go to Parameter Store. And we're going to create a parameter. So this is basically just a key value pair. Again, it could represent a database username, a database password. It could be an SSH private key, anything of that nature, right? So let's go ahead and just say create parameter. And one of the options that you'll have when you create a systems manager parameter is the ability to select a parameter tier. You have the option of choosing either standard or advanced tier parameters. And you'll see right here in the description, it says that parameter policies and sharing with other AWS accounts are not available. So we have to choose advanced, where it says advanced parameters share with other AWS accounts. So we need to make sure that we choose that advanced tier in order for this to be shared. So let me create a password, or a parameter, I should say, called StratusGrid01-password. And we'll say this is a database password for my SQL. And then down here, we'll just use a string value, and we'll just set it to my cool DB password. All right, so now that we've done that, we can say expiration policy if we want to. I'm just going to leave that. I'll do my standard owner tag down here, owner Trevor Sullivan, and then we're going to hit the create parameter button to go ahead and create that. So now we need to add this advanced parameter. So you can see it's advanced tier. We're going to add that to our existing resource share. So once again, in the parent account, Resource Access Manager, go to Resource Shares, then we'll choose Modify, and then we'll go down here to Resources. We can specify Parameter Store Advanced Parameters, and now we can choose the ARN of that parameter that we want to share across AWS accounts. So we're going to include that in our list. So now we have 6 subnets, 1 placement group, 1 SSM parameter. SSM is just short for Simple Systems Manager, which was the original name of the Systems Manager service. We'll just use the default managed permissions for all 3 of these resource types. Hit next. And then, of course, we already have the OU selected here, so we'll just do next. And then finally say update the resource share. All right, so now that we have updated the resource share, we can come back to the child account. So I'm going to context switch over to the child account here, and we can go to the Systems Manager service. And I'm going to show you something, another little gotcha here with the Systems Manager service. So if we go to Parameter Store here, we should be in the Oregon region here, right? So we're going to choose the correct region. If we came back over here, our resource share is in the Oregon region, which also means that our resources that we've shared are in the Oregon region as well. And we're just going to confirm by refreshing here that indeed the Systems Manager parameter has been shared. Now here's the little gotcha. Even though we're in the correct region here, we actually can't see that Systems Manager parameter from the AWS Management Console. So we could see subnets, we could see placement groups in the AWS Management Console from the child account, but when it comes to Systems Manager Parameter Store, advanced parameters, we can't see those show up in the console here. So we can verify that we have API access to those parameters by going to Cloud Shell. So Cloud Shell is just going to give me a terminal-based environment with the permissions that I'm currently logged into the AWS Management Console with. And then we can run a simple AWS CLI or AWS PowerShell command in order to list those parameters to make sure that we actually do have access to retrieve them. So what we're going to do is say PowerShell here, and then there is a PowerShell module. So if we do get module dash list available, there should be one called AWS, I think it's called Simple Systems Manager, Simple Systems Management here. And this module here exports a command called get SSM parameter list, and there's a parameter on there called -shared. So by default, get SSM parameter list is not going to return any parameters that were shared from another account. But if we say shared true in the API call, then that's going to list the SSM parameters or systems manager parameter store advanced parameters that have been shared from other accounts. And we can see right here in the ARN that the resource does actually, in fact, belong to a different AWS account. Even though we're logged into 6546, we're able to access that advanced parameter across from a parent account. So that's kind of how Resource Access Manager works. I'm going to leave playing around with other types of resources like dedicated hosts or a bunch of the other supported resource types that are over here in the documentation. I'll leave that all to you, but at least we took a look at how placement groups worked. We took a look at how subnet sharing worked, as well as how security groups don't actually work with sharing. And then we also took a look at how to share advanced parameters across AWS accounts. If you're following along, be sure to clean up your resources so that you're not spending money on resources that you're not actually consuming. Make sure you're cost optimized. So go back, do your cleanup, and then thanks again for watching this video, and we'll see you in the next video. Take care.